Let's consider the operation of a diode in a circuit. Here we have what is called forward bias. Forward bias. In other words, in forward, we're going to make it conduct. So let us suppose, for example, I have a 10 volt supply. Then this is positive and it is connected to the anode on the diode. The other terminal is the cathode. So with 10 volts connected, I have enough potential voltage in the circuit to make this diode conduct. And what will happen is we have a series circuit, and once the diode is conducting, its voltage will stay constant around 0.6 of a volt. So with a 10 volt supply, that will leave us 9.4 volts across our resistor, the circuit. So this is forward bias. We make this conduct, and what is happening is a current is flowing. So current is flowing around the circuit. If I were to increase the voltage, so let's change this from 10 to 20, we will still have 0.6 volts across there, and we'll now have 19.4 volts across the resistor. In reality, what will happen is, if we keep increasing this voltage, let me choose an arbitrary number, let's make this 30 volts. We've increased the voltage quite a bit. What will probably happen is the voltage across the diode will creep up to maybe 0.7 volts, in which case the potential across the resistor will now be 29.3 volts. So there is a clear point here, and the point is that once the diode is conducting, the potential difference, the voltage across it, is fairly constant at around 0.6 volts. If we apply sufficient voltage and pass sufficient current through the circuit, it will creep up 0.7. But for this course, for the level that we're at, 0.6 volts is the magic figure at which the diode turns on, and it holds the voltage across it fairly constant. So that was forward bias, turning the diode on and making it conduct. Let's look at reverse bias. So in this particular diagram, I've changed the diode around. So here is the anode, here is the cathode, and yes, we tend to use the letter K for cathode. So anode, cathode, this is now the wrong way around. This will block the flow of current. So in this circuit, there is no current. This will block the flow. The truth is, in the real world, this will have a current going through it, but it will be in nanoamps, 1,000 millionths of amps. It's so small, it's negligible. It doesn't matter. So in reverse bias, we have no current flow. In forward bias, we have current flow. I turned the diode around and I left the supply the same. I could have turned the supply around and left the diode the same. It would have had the same effect. Okay, reverse bias, forward bias. Remember the number of 0.6, that's crucial.